All right, welcome. Today, we are breaking down exactly what it takes to launch a career in aerospace engineering. We're talking about everything from designing supersonic jets to building the rockets that might just take us to other planets one day.
You know, it all really starts with this one big question. This is the core challenge, the thing that drives this entire field to constantly push the boundaries of what we all think is possible.
And the answer to that question? Well, it's aerospace engineering. And yep, it is quite literally rocket science. Okay, let's dive right in. So, what does it actually mean to be an aerospace engineer? What's really at the heart of designing and building these incredible machines that conquer the skies and venture out into space? The best way to think about it is like this powerful fusion of different disciplines. You've got the precision of mechanical engineering, the fundamental laws of physics, and the incredible logic of computer science, all of them working together for one ultimate goal, to master flight. The day-to-day work, it's incredibly diverse. I mean, one day an engineer might be in a wind tunnel trying to get the perfect shape for a wing to save fuel. The very next day, they could be stress testing a rocket structure to make sure it can survive the insane forces of launch. Their work really does impact everything, from the GPS that got you here to designing missions to Mars.
But, the job isn't just about dreaming up the next big thing. It's also about making sure that everything that flies is as safe as it can possibly be. And a huge piece of that puzzle is learning from the times when things go tragically wrong. I mean, just think about it. When you're dealing with these extreme speeds, incredible altitudes, and intense pressures, there is zero room for error. When something fails, the cost isn't just about money. It can be measured in human lives. This is where aerospace engineers basically become forensic detectives. Failure analysis is this super meticulous, systematic investigation to figure out not just what failed, but the entire chain of events, every single decision, every tiny flaw that led to that failure. Now, this is what's so fascinating. You see how a massive, catastrophic event can be traced all the way back to a microscopic flaw. An engine failing on a 747 actually started with one single imperfectly made cooling hole in a turbine blade. By finding that tiny, almost invisible root cause, engineers can create entirely new manufacturing processes to make sure it never, ever happens again. Okay, so the field of aerospace is absolutely massive, and it has a ton of different specializations. You don't just become a generic aerospace engineer. You really get to choose a specific mission, an area where you can make your mark. A question that comes up all the time is how this is different from its close cousin, mechanical engineering. And while they overlap a lot, this slide gets to the core of it. You could almost say aerospace engineers are the visionaries, asking how high and how fast can we possibly go, while mechanical engineers are the pragmatists, making sure that vision can be built reliably and safely. So within aerospace, you pick your domain. You might focus on vehicles that stay inside our atmosphere as an aeronautical engineer, or you could work on things that leave it as an astronautical engineer. You could specialize in the raw power of propulsion, the complex electronic brains of a craft in avionics, or even the advanced materials that make it all possible in the first place. This all sounds incredibly exciting, right? Designing rockets, testing wings, but what does the day-to-day reality of the job actually look like for most engineers in this field?
This is probably one of the biggest questions aspiring engineers have. Is this a hands-on job where you're in a lab getting your hands dirty with hardware? Or is it mostly staring at computer models and doing paperwork? Let's find out. Well, the truth is, it really, really depends on your specific role. You might spend your days deep in computer-aided design, or CAD, making 3D models. Someone else could be running complex simulations to see how air flows over a wing. Or you could be in a lab physically putting hardware together for some serious testing. And for some people, the job is almost never at a desk. I mean, check out this test engineer on Reddit. Roles that are focused on testing and integration can be extremely hands-on, putting you right on the factory floor or the launch pad, working directly with the real hardware. So, let's say you're inspired. You see the challenges. You feel the excitement. How do you actually turn that passion into a profession and start your own journey to the stars? Now, this is a crucial point. A successful career here isn't just about being great at math and physics. It's really about having the right mindset. It's about being endlessly curious, being patient when you hit a wall, and, maybe most importantly, being collaborative. Because, let's be real, nobody builds a spacecraft by themselves. And that unique mix of technical skills and a problem-solving attitude, it is in very high demand. The pay definitely reflects that. For instance, the average starting salary for a propulsion engineer in the US is over $90,000, and that can grow a lot with experience.
An aerospace degree can open doors all over the place. You could end up working at iconic agencies like NASA or for pioneering companies like SpaceX that are completely rewriting the rules of space travel. You could be at major defense contractors or even innovative startups developing the future of flying cars.
For students who are in the thick of it right now, like Jennifer He, the appeal is so clear. It's not just a job, it's the chance to tackle puzzles that don't have easy answers, and to be part of this really tight-knit community that's driven by this incredibly ambitious goal. And for those who are already in the field, like senior spacecraft systems engineer Divya Jindal, the advice is simple. Get your hands on some real experience as early as you can. Internships, university projects, that's what gives you a real feel for the industry and helps you truly launch your career. From developing greener, more sustainable aviation, to engineering life support for deep space exploration, to building the next generation of satellites that will connect our world, the next great leap for humanity is being designed as we speak. The only real question is, what part will you play in it?